I say, well, I have so many rooms of furniture, and I wanna know how many times you're gonna have to come, I need to know how many rooms can you get on that truck, right? You may be able to get them all in there, then we just need one. But if you tell me each truckload will take one room of furniture, and I know I have 10 rooms, then I know it's gonna take 10 times, you see. So sometimes too, when you read these, and it's not like you're used to holes in the ground and trucks loads of dirt. Change it around to something. You say, okay, if I need to find, you know what I mean? Change it around to something that makes sense to you. Like I said, okay, if I got all these rooms of furniture and I want to know how many times the truck's going to have to come, I need to know how much each truck can take. Because it's going to be, it doesn't matter that it's math, it's going to be logic. Look at 11. It says the diagram at the right shows a large rectangular block with a cylindrical hole through it. We look over there, is that what we see? There's a rectangular block, and we see that hole going straight down the middle of it, right? Okay. They've told us that this rectangular block is 15 feet wide or long, or whatever one, doesn't matter if it's length or width, 10 feet tall, right? And 10 feet wide. That's the dimensions of that box, right? Then we got this hole going down the middle of it. They just cut it all out. Kind of like those area problems we had, didn't it? You got that hole in the middle, all right? Which of the following expresses the volume in cubic feet of the concrete that is required to construct the block? We don't want concrete down that hole, right? You tell me which one it is then. Look at each one of them. Think logically first. How am I going to figure out how much concrete I need for that whole big block, but not that hole in the middle of it? What are you going to have to do with that hole?
Subtract it.
Subtract it, right? So it can be either 1, 2, 3, or 4 because we see subtraction, right? We got to subtract the volume of that because that has length, width, and height too, right? Which one of those shows the volume of that circle? How do you find the volume? Ooh, good, you guys are good. It's pi times the radius squared times the height, right? What is the radius of that hole, of that round, of that cylinder?
3.
3 is the radius, right? Well, they didn't put 6 here anywhere, so they didn't try to fool you that way. The radius is 3 squared. So we're going to first have to find the volume of the whole thing, right? Which is length times width times height, right? Which is 15 times 10 times 10. That's the whole thing. Then I'm going to have to subtract out that whole. That's why number 1 is, as you said, the correct answer. What is, because the second one does what? It just has the area, doesn't it?
Yeah,
And not the volume.
Yeah.
It has the area. 10 times 10, that's just that surface space. Pi times the radius squared is just that flat circle. But that circle goes all the way through 15 feet, you see? And that cylinder is all the way 15 feet. So we know that's not it. Number 3, same thing, it has a 15 times 10. But that doesn't give us the volume of that whole rectangular block, does it? It does have the pi times radius squares times height for the cylinder, but it doesn't have the other part of the rectangle. Number 4, same thing. They don't even have pi in there. Number 5, that's just the cylinder. It doesn't have the rectangular part, right? So again, once you figured out what you had to do first, then you looked for the numbers that said that. You knew you had to subtract that whole out of it because when you build, if I'm trying to build that figure there, we want it to be that block, but we want a hole down the center of it. We don't want concrete covering that hole. So we got to subtract that hole out of it. Follow? Deborah? Okay. And then 12, which of the following represents the area of a circle with a diameter of 30 inches? Tell me what you're going to multiply to find the area of a circle with a diameter of 30 inches. I don't even want the answer. Just tell me what you're going to multiply to find that. How do you find the area of a circle?
Diameter times.
Is it diameter times pi for the area?
Radius times pi.
Is it just radius times pi? Diameter times pi is for the distance around. Remember D, distance around. Area, you do use radius, but it's not just radius, it's radius what?
To the square.
Radius squared. So what is the radius of this circle? What's the radius of the circle? 15. You'd have to say what? 15 times 15 times pi. Okay? Follow? Got it? See, you understand that?
No.
Pi times the radius squared is your formula, right? Isn't that the formula?
Mm-hmm.
What's pi?
3, 1,
3.14. What's the radius?
15.
Times 15 is radius squared, right?
But okay, I get it.
You need to always write the formula first before you try to solve these. Don't just try to do it. You have to write the area is equal to pi times the radius squared, and then just substitute. Pi times, you told me the radius is 15, right?
Mm-hmm.
Because it's half of a diameter. They told us the diameter was 30. The radius has to be 15 squared, just what it tells you it has to be. Just substitute. Squared means 15 times 15 times 3.14. You do all that, you're going to get the area. Right? No, I didn't get the answer. We didn't care about the answer. I just cared that you knew, because if you know what to do to get the answer, a lot of times you have a calculator to use. As long as you put in the right numbers, you're going to come up with the right answer. But that's what you'd have to do. Think of the formula, substitute what they give you in the formula, and just do what it says. Dollar? Or you still not really? Okay, it asks us, what is the area of a circle that has a diameter of 30 inches? They want to know, what is this space? They have told us, people smarter than us have told us, to find this space, which is called area, we multiply a constant, which is pi, times whatever the radius of that circle is, times itself. That's nothing we have to think of. That's what they tell us we have to do. So we just have to do it. It says if you take 3.14 and multiply it times the radius of that circle times itself, you'll find the area of that circle. Okay? If they told us that 30 was the diameter, then we know that 15 is equal to the radius, because we know the radius is half of a diameter. The radius is just from the middle to a side. You see what I mean? Just half of it.
Radius is half.
Radius is half of a diameter. If they ask us what's the perimeter or circumference of this circle, and the diameter is 30, to find the circumference of the circle, it is pi times the diameter, is the formula. So I take the 3.14 and multiply it times the 30, because that's the diameter. But for the area, we don't use a diameter. We use a radius. So if they give us a diameter, we have to first change it to a radius to fit the formula, which means we have to take half of it. That's the radius. Then we have to square it, because the formula says we have to square it to find the area. Okay? Okay?
I get it.
You gotta go.
Yeah.
Pray for us as well.
Huh?
Pray for us as well.
Oh, okay.
Well, for me, I don't speak for everybody else, maybe they don't wanna be prayed for. Maybe they all prayed up.
You that much prayed up.
Minutes daily, moment by moment.
Minute by minute,
Yeah,
second
I'm
by
telling
second.
you. Yeah, second by second, huh?
Man.
We're gonna talk about the Pythagorean theorem, which is
How much is these books, Miss Harris?
$20.
Who are giving to? Cause
Front
that's
desk.
another problem. I don't have a book.
Front desk. Just telling you want a book. Page 271.
That's the page you want us
We're
to
gonna be
do?
working on, that starts explaining it. We're gonna do page 274.
Okay.
And where'd you put your test? Teresa?
Yes.
Do you have time to score two, math math OPTs?
Yeah, I got a space
you-
in here.
Would you guys take it to her and she'll score it for you? Thank you. Thank you. Okay, 271. Says a Greek mathematician named Pythagoras discovered a special relationship among the sides of a right triangle.